Hello, everyone. Today is April 8th, 2020. This is the Data Protection Workgroup meeting. This meeting will be recorded and uploaded to YouTube. Let's get started. I'll first share my screen. So today we have a couple of things on the agenda. Rafael will talk about backup with the different Kubernetes API versions. This is something he started to talk about in the last meeting, and today he has some slides to share. And then next is Ashish, who will talk about some issues that he ran into. We're trying to use CSS Snapshot to do backups. And then I will give an update on the execution hook design. All right, I'll stop sharing. So Rafael, you want to share yours?
Absolutely. Can you enable?
You want me to? Oh, okay. Let me see. Allow. I don't see an option to enable. I think you should be able to share once I stop the sharing. I don't. Yeah. If you can, then I will. Maybe they did something to make this strict, but I do not see an option to enable share. There's a allow record. There's a put on hold. If you try it, if you cannot, then I will share.
Yeah, I got a message like host disable, attendee screen sharing.
Oh, okay. Okay. I will share then.
Yeah, the Zoom
I think it's, yeah,
there are
some problems. Yeah, there are some problems with the abuse of the Zoom. So that's why they are making this. Let me share it. It's okay. I can share it.
If you feel comfortable, you can share and give me control because it's an animated presentation. So you're gonna click to go through a couple, the points and a couple animations for.
Okay, I don't know if I can. I don't think I can give you the control. Probably not. Okay, so let me share my screen. Okay.
Can you click the present?
Okay. Yeah.
You probably I have to ask you to click next.
Yeah, that's okay. Yeah, I don't think I have an option to. Let me take a look again. I don't think there is any option to allow you stop video spotlight. Yeah, I don't think I can do that. Okay. So yeah, you why don't you just go ahead and let me know when you click on next.
Sure. So first of all, thank you everyone. Very quick intro. My name is Rafael Brito. I work for VMware Office of CTO. Recently, I've been working closely with the Velero dev team. The majority of them are here on the call. Carlisa, Nola, Steve, Ashish, and I've been involved on this project to make Kubernetes migration easier. And that's why we are here today to discuss about API groups. So in the beginning, I'm gonna go to a little bit basic information, and apologies on that, just to make sure everybody has the same page in terms of knowledge. So what is Kubernetes API groups? Can you click, please, next? A couple of times.
Oh, hold on.
Yeah.
Does not look like,
yeah.
Okay.
Yeah.
Is that right? Okay.
So the conventions of API, or Kubernetes APIs, every object has a kind, is a kind actually, and there is an object schema, right? So an object can be a pod or a horizontal pod scaler. And this I'm gonna use a lot about the example of HPA, which stands for horizontal pod scaler, because it's a great example for API groups. So each item or object is a kind. Next, please. So the collection of the kind, it's a resource list. So kube control get pods, gonna get all the pods, which is all the type pod. And the collection of resource lists are grouped into an API group, which is group and version. So examples are, auto-scaling is an API group, which horizontal pod scaler are part of it. Next, please. So in a very long story short, the dependency tree is like each item is a kind that belongs to a resource, and a collection of resources belong to at least one API group. Next, please. So horizontal pod scaler belongs to horizontal pod scalers that belongs to outscaling /v1. It's an example. Next, please. Continue on in the introduction of API groups. Kubernetes is evolving very rapidly, right? And the new object schemas are rollout. They're grouped and roll out as new API groups. Next, please. Next. So there are two types of API groups. The native Kubernetes, they are baked into the API server, right? And the usual suspects, outscaling, policies, scheduling, apps, and so on. I took a quick look at the 118 API server source code. There's around 20 API groups, right? There's some special cases on API groups. Next, please. The core API group, which are fundamental objects of Kubernetes since version 1 or even before. Pod, service accounts, persistent volumes. And the funny thing is this group does not have actual name when you invoke or request API information about this group, but it refers core. Next, please. There are other situations where a resource belongs to multiple API groups for to be compatible, right? Daemon set, for example, belongs to apps and extensions. Next, please. And finally, there is the non-native Kubernetes API groups, the ones that are extensible by the users using CRDs. And those users can create their own versions and roll out their own versions. Next, please.
Thought I
clicked. Sometimes you gotta click a couple of times, yeah.
Okay, again.
Yeah.
All right.
So each running cluster has a list of the versions of the API group is supported. And it's an array for each API group. And from this array, one entry is flagged as a preferred version. Next, please. Those preferred versions for the native API groups are hard-coded on API server. It's not a configurable parameter. So if you have 3 versions of the API group, using outscaling as an example, only one is preferred and is hard-coded on API server. Next, please. The only arbitrary option for the users, they can enable, disable API groups versions and requires an API server restart. Sometimes users enable like alpha versions. Next, please. Next. So there's a couple command lines, how to retrieve information about your cluster in terms of what versions they support, and what the preferred version. This one on the screen, /APIs, you're gonna see all API groups and versions and preferred versions. Next, please. Next. This other command line retrieves all the resource lists of your cluster and respective API groups and kinds. Next, please. Next. This is a quick example how to get the core version of the cluster, right? It's just /API. Please note, it's not APIs, it's just /API. Next, please. Next. Okay, this is a very picture of what we are talking about. So Outscaling is a native Kubernetes group. This is a 116 cluster that I took in snapshot. I took this command line. So you can see that there are 3 versions for this API group: V1, V2 beta 1, V2 beta 2, and the preferred version is V1. Okay. Next, please. Next. So we did a quick inventory. Next, please. This is the changes of preferred version across major Kubernetes version. I'm gonna apologize because the columns start with the most recent to the older. But you can see that between 115 to 116, we got a change on the API extensions. Scheduling change between 113 and 114. And this, every time there's a preferred version changes, there is some slightly changes on the object schema, and we're gonna talk about this. Next, please. Next. Next. So what is really concerned is when API group versions are eliminated from the versions of Kubernetes. So in this example here, apps v1 beta 1, apps v1 beta 2, after Kubernetes 116, they're no longer supported. Okay. So that means that if you try to create some object using that schema, the API server can reject. So that's another inventory that we ran across the versions. Next, please. So there we go. Here we go. Why we need to care about this, right? That's the problem statement. You know, different versions of Kubernetes support different API groups, and we remove, when I say we, the community, the Kubernetes maintainers and distros, remove all the releases. Right? There is some versions that we keep, but you don't want to maintain in all versions of the schemas. Next, please. This is very important when you start to think how to migrate workloads from one major Kubernetes to another and skipping multiple releases. That's very common. I came from the enterprise world. You're gonna be surprised how old Kubernetes is out there in production. So if you need to migrate to a new version, you're gonna end up skipping multiple releases. Next, please. So Project Velero does migration. Be very clear. There's pages and documentation how to do it. But today, Velero only backs up the preferred version of the API group or each cluster. Okay. Next, please. So the motivation for us and for my team is really develop a mechanism for us to take a backup on any cluster and restore it to any other cluster, regardless the version of Kubernetes, transparently, without the user being punished. Next, please. So very quick, I want to show how the preferred version works. So the user goes and connect to the API server and said, give me an object, HPA, horizontal pod scaler, v2 beta 2. Next, please. So the API server is gonna go and see the object, HPA v1, because it's the preferred, is stored on etcd as a preferred. Next. So because the user requests a v2 beta 2, there's a webhook. Next, please. And there is a conversion from v1 version to v2 beta 2. and next, and finally gets back to the user. Okay. So that's how the magic happens, right? The conversion between the versions. And I gotta tell, very honest, for me, it was very difficult to understand how this happens. And I put another slide next to see with my own eyes how this conversion happens. So I put in two columns the same object, one on the left side, the V1, which is stored, because remember, that's the preferred version for HPA, and V2 on the right side. Next. So they're the same object. Okay, I'm gonna put snippets of the same object. Next, please. So first, on the left side is, you can see the API version is outscaling V1. Okay, there's some annotations. Next, there's more annotations. Next, and here I highlight that this object was created as a V2 beta 2. So at a given point in time, I do a kubectl apply, and I wanted to create this V2 beta 2 object, but I'm getting the version 1 on the screen. Next, please. This schema has a very old field, which is a V1 field, but wait a minute, created is a V2 beta 2 that does not have this field, but the conversion happens on the API server. Next. So let's take a look on the V2 beta 2. Again, it's the same object. The API version is V2 beta 2. Next. Here's the fields that I created with, for people that are used to HPA, V2 beta 2 has much more instrumentation, how you do outscaling, such as packet per second. And V1 version doesn't know what is this metric is about. Next, please. And the conversion from one to another it happens from the webhooks and API server. Next, please. So how we are doing in terms of Velero backup. Next. So today on version 1.3, we take a backup of the preferred version. So that's what, when you take a Velero backup and a tarball and you explode, you're gonna see the directory structure. So if I open that JSON file, is gonna be a HPA v1 of my object. Okay, next please. So the future backup format, we're gonna add all API group versions. Next. So we continue to have the same directory structure to be compatible. And now we have different directories with each version of the object, and it's the same object. For the version that is preferred during the backup time, we add the string /preferred version. So basically it's the same object with different schemas under different versions. Next, please. And that's where we are right now in terms of restore. How are we gonna make decisions to which versions we're gonna restore? Today, because we have a single version, which is the preferred version of the resource cluster, that's what we restore, right? Next, please. We are in discussions how we're gonna make decisions of use the version. Next. We can, it's up for discussion in the community. If you're Velero user, I really recommend you join the community calls on Tuesdays. I think is 11 Pacific time. That's where we discuss all this kind of good stuff. So one of the proposals is really detect the restore is being done in a different version of Kubernetes, and then you use a discovery API to find out what's the new preferred version, and then use that for restore. Next, please. Right. In this case, we're gonna use the target cluster preferred version as the version to be used. Next. still in discussions a little bit more aggressive way to do restore, possibly a plugin. Then you can always use the latest version. And if the version doesn't exist or is not supported by the target cluster, you kind of do some other mutation for that. You got to remember that this whole point is to really prepare for the future, right? Today we have 20 API groups part of API server. If you install any other application on Kubernetes that extends Kubernetes, we possibly talking about dozens of API groups by users, and we got to be prepared to have all these multiple versions across. And of course, the possibility to really skip level Kubernetes migration. Next, and that's pretty much the presentation. I want to thank you and open for Q&A and have the Velero team back me up if you have any questions about Velero itself.
Would you have any situation where you want one particular field that is on the target cluster, but you couldn't get it from the source?
I'm not aware of any particular problem like this, because luckily the preferred version doesn't change a lot across the releases. But I think the tricky part, and when you start to really handle CRDs, which is you don't have a tight control what the users are extending. That's my take. I don't know if anyone else from Velero want to jump in and give their opinion.
Could you repeat the question?
Oh, I was basically asking if there is any situation that you actually need a field on the target cluster at the restore time, but you couldn't get that from the source, from your backup, basically.
I don't think we've run into that so far, but I don't think it's an unrealistic scenario. I think we definitely could run into that, especially if we only grab the preferred version.
I think we never encourage this because the API server is doing a great job converting among those versions. But we just rely on this conversion at this point.
Yeah, I think like if a user is trying to use, like with Raphael's example, if they're trying to use the horizontal pod autoscaler at v2 beta 2, if they're using something that's ahead of the preferred version, then Velero is going to get the preferred version at v1. And when Velero goes to restore that, it's going to restore at v1, which is not what the user was using. They were using v2 beta 2. So I think that might be a situation where Valero's not doing quite what the user wanted, where it needs those fields that are only present on v2 beta 2. But I'm not aware of other situations like that. But that's not to say that they aren't out there.
I think that is also one of the things that Raphael is taking into consideration when performing restores. What happens when whatever version that we want is not available with the API server? That is going forward. Yeah, not really sure if we've encountered that problem yet or so far.
Yeah, the one example that we took is someone took a backup on Kubernetes 1.7, want to restore on 1.17, and the API group version was not there, was not a match, right? You can argue that 1.7 is very old, but basically, I think with the more and more users of Kubernetes, we gotta kind of prepare for this kind of situation.
Yeah, I think you're looking right now at like people migrating, but there's also the archive case, and we might want to start thinking about what is a reasonable thing to do for archival. Are you expecting that your archive is actually going to restore a Kubernetes cluster, or do you want to start saying, hey, your data is going to be archived, but other stuff has to be upgraded? I think that's something we should probably think about.
So I got a question. So if there's a missing field that's in between version, how do you deal with these when you restore?
I go with Nolan said. It might happen but up to our knowledge, we didn't see this happening, right? And this missing field today is being handled by the API server. The API server is lifting the weight here, converting all those versions, and even though a given point the API server does this conversion on the source cluster, then Velero takes a snapshot of that version, right? What is happening, this missing field, potential missing field can be happening over there on the source cluster. And that's what, the reality is there's only one version being stored on etcd, okay?
Okay.
There's only one version, even though I created that object as a v2 beta 2 with a lot of new fields. What API server did is pick all those new fields and set up as annotation of the v1 object. So if you get the v1 version of the same object, all these new fields of the new schema are baked as annotated. So the API server does this magic. So there's nothing that Velero can do to tell API server how to convert back and forth. What Velero can do is really take one copy of each of the same object in different format.
Okay, I see.
So for longer term views, when the API server for native Kubernetes objects, when these webhooks start going away, for example, with apps, I think Rafael, you talked about having a few folks on your team working on plugins for Velero that would essentially do the same work as these webhooks. So I don't know exactly how you're going to do that. And I think like this slide that's on screen right now, I think a lot of the restore logic is up in the air at the moment. Like the work you've done so far is to make sure we have the information that's in the cluster right now in the Velero backup. And then we're going to figure out what we do with that on restore, whether we make a bunch of plugins for certain things to allow it to do the skip versions. For close enough versions, we might be able to just say, hey, upgrade the version and here you go. But if like keying off of what Dave said, if we start doing archival or on a long enough time horizon, Velero may have to carry plugins that does some of the webhook logic to say, hey, I see you have this version, and therefore I need to do this logic to insert these fields and make these assumptions that the webhooks were doing. So I know early on in this project, Rafael, you talked about having a group of people like looking at those webhooks, maybe porting some of that logic to happen elsewhere, so that we could go with it. But I think some of these questions are still to be answered. I don't know that we have all those answers yet.
When you say it's going to disappear, the webhooks, what do you mean by that?
So what I mean by that is like take apps v1 beta 1 in Kubernetes 1.16. That version was removed from the API group in Kubernetes 1.16. So you have to use apps v1 for your deployments. Eventually, Kubernetes will remove versions from the API groups because they just don't want to maintain them anymore.
Okay, but then you're talking about you want to, if Valero want to support it longer, then you will need to.
Right. It's to give the backups that Valero generates a longer window to allow people to jump versions. And if, for example, you had a v1 beta 1 deployment, you could deploy it to, as an example, Kubernetes 1.22, to have some sort of way of translating that without the webhook being inside the Kubernetes API server.
Okay.
I have a follow-up question. Outside of the Valero use case or cluster migration and backup use case, let's say I'm just upgrading Kubernetes and the store version, preferred version, changes from one version to the next. Are there any mechanisms in Kubernetes that would proactively update the state in etcd, or we just have to wait for the writes to happen for the state in etcd to change? But what's the process?
From my observation, that's why when you upgrade Kubernetes, you usually want to do incremental upgrades, because the next minor version, or when I say minor, is 1.x. The X is considered minor, right? 1 is considered major. So when you do these upgrades, the next one, it will support all the previous preferred version, okay? The complications start to happen when you're running so many releases behind that your preferred version of that old release will no longer support it on whatever cluster you're going to. But if you do incrementally, you're covered. Does it make sense?
Yes. So we just have to incrementally update from one minor version to the next until.
Yeah. And the reality is, as I said, I came from enterprise world. You have something in production, you cannot just upgrade every 3 months, right? And that's a challenge that Office of CTO, where the group that I work for VMware, strategically trying to solve for the users to be able to move those workloads without the operational process to every 3 months you have to stop your workloads, upgrade, and then just, it's not feasible for many workloads out there.
Mm-hmm. So let's say you go from, just to follow up. So let's say you go from one minor version to the next minor version. Does the state in etcd change when the objects are being modified, or proactively some background process changes the state?
It changes on etcd if the preferred version changes. So that first table that I showed with all the releases, scheduling IO, scheduling.kubernetes.io changed the preferred version from 1.15 to 1.16, right? So if we upgrade from 1.15 to 1.16, now your etcd object stored is going to be a different schema. Okay,
so as soon as you upgrade master, something, which is, I don't know exactly what in Kubernetes, updates the state in etcd.
Yeah. If you upgrade in place or even migrate using Valero, that's going to happen for you.
In fact, for a lot of internal APIs, there's actually internal schema that is not versioned. That is what's actually stored in etcd. And so there could be, that could differ. I don't know an example of when that differs from preferred, but they do have the flexibility of adding things in there that are not in the preferred version, for example. So if they're supporting, for example, V1 as well as V1, V2 beta something, then there could be extra information in there that would support both V1 as well as V2 beta something.
In your restore proposal, do you consider that when something wrong happens during the restore, do you have a mechanism to roll back to the previous status?
It hasn't been coded yet, but I like this idea to, you know, to try the source cluster preferred version as well.
Mm-hmm.
Yeah. I'll be honest, taking the multiple copies of the same object was almost like one API change on the discovery side. The real work is when you make decisions what you use it. Okay.
Okay.
And then and that's why I cannot stress enough to, if you guys interest, join the community call where we discuss all this.
And currently, Valero does not have any rollback on restore, but it will try to if it will try to restore an object, and if it encounters an error from the API server, it will just log it and move on. But right now, it has no rollback mechanism.
Okay.
It's already 40 minutes past. We probably should move on to the next topic. So yeah, it's a great topic, and definitely this is a very important issue to consider when we are doing backup and restore. Thank you, Rafael. Let me go to the next. I think next one is Ashish. Oh, Ashish, can you talk about the issues that you run into when you're trying to use CSS snapshot to do backup and restore?
I think, well, for all the issues that I opened, there were workarounds, and in some cases it is.
Ashish, can you just to bring everyone up to speed, and you just talk about what is your use case, what are you trying to do?
Sure. So what we are trying to do is we are trying to build capabilities into Valero to perform backup and recovery or restores of CSI backed volumes. So leveraging the CSI APIs and types, we want to perform volume snapshot operations and volume restore operations for CSI, for volumes backed by CSI drivers. So that's the use case that we were trying to solve. In doing that, there were a couple of issues that we ran into around how the relationship between the volume snapshot content object and the volume snapshot object. So for folks who are not familiar, these are the API types for the implementing the CSI volume snapshots. So one of the I'm trying to recollect the order in which I want to present issues that I faced. And I think I opened 3 issues. One was for to make sure the relationship between the volume snapshot and the volume snapshot content is like 1-to-1, and then that is there are 2 kind of scenarios for like volume snapshotting. One is like dynamically created volume snapshots, which is representing the scenario of there's a CSI backed volume and you're trying to take a snapshot, at which point you create a volume snapshot object, which in turn creates a volume snapshot content object. So that's the dynamically created volume snapshots. And then the other scenario is where you want to create a volume from a volume snapshot that is already existing. So that is where you would statically bind a volume snapshot to a volume snapshot content and say, and give it to the CSI APIs to create a volume off of that snapshot. So one of the issues that I ran into was I wanted to reuse the dynamically created volume snapshot content for provisioning and pre-populating data into that volume. And turns out that doing that kind of violates some of the assumptions that was baked into the design of the volume snapshot objects. And the right way to do that would be to explicitly create a volume snapshot content to statically link the volume snapshot and the volume snapshot content. I'm sorry, I should have drawn pictures because that kind of makes it a little easier to follow. So I apologize for that. So that was one of the issues. And then the other issue that I opened so that was the workaround for that problem. The other problem was the relationship between the volume snapshot and the volume snapshot content, which is one-to-one. I wanted to know if that can be one-to-many, like many volume snapshots can refer to the same volume snapshot content. That way you can have multiple volumes provisioned using the same volume snapshot content. So that also was a non-supported scenario. And the workaround or the right way to use that would be to create multiple volume snapshot content using the same snapshot handle. So you don't need multiple volume snapshot at the storage provider level. You just need multiple volume snapshot contents at the Kubernetes level. And then you can resolve, instead of having one-to-many, you can have many one-to-one mappings. So that was the workaround. The other issue that I opened was around the life cycle of the volume snapshot contents. That is the issue that is still open. So for volume snapshots, there are two kinds of retention policies, or it's called as deletion policies. One is whether or not you want whether or not you want to retain the volume snapshot content when the volume snapshot goes away. That's basically what the policy is defining. So the issue that I opened up was if somebody accidentally deletes their volume snapshot objects, then that means creating the volume snapshot content that was created for that volume snapshot object also goes away on deletion, which means the snapshot that was taken is not useful beyond that period. So you cannot restore using a previously taken volume snapshot if you accidentally delete the volume snapshot object. So I wanted to decouple the life cycle of the snapshot in the storage provider with that of those Kubernetes objects. So that's the issue that is still open, and there have been a few discussions. There has been some discussion on that. I'm trying to pull up the issue number.
Ashish, can you clarify that just a little bit? So you're saying that if the snapshot object is deleted from Kubernetes, you're having difficulties restoring the snapshot that's in the storage system?
Yes, because so if I'm using a deletion policy of delete, which is me saying, hey, if the volume snapshot goes away, go ahead and delete the volume snapshot content and thereby the volume snapshot in the storage provider.
Right. That's like, yeah, that's not a good thing to do, but yes. Okay.
But that is the design, right? You tell me to delete it. That's why we have the policy, right? You have the delete policy or retain policy.
It's the only way to delete it.
I'm sorry?
Yeah, why this is another this is another desired behavior?
You do want a way to delete it, right? Otherwise you can never delete anything. That's a problem too.
Yeah, you need some way to control this.
Yeah. So if you use retain policy, then you will have your physical resource reserved.
Yeah, I mean, there's some problems that I think exist that, say, for example, you back up cluster A, and that took a set of snapshots, and that continues to have the Kubernetes snapshot resources there, right? You make a new cluster and you restore into that, and now you create a new set of snapshot resources that point to the same snapshot. Now, say you're just doing this for testing and you delete your snapshot resources in cluster B. If you didn't change your policy, if your policy was delete in cluster A and you set the same policy in cluster B is going to delete the snapshots, even though cluster A is still referencing them, right?
If you have one of them that says delete, the policy is delete, then it's going to delete it. That is right.
Yeah, that's
I don't think
dangerous.
But I
I
don't think this is a problem with the controller. This is the problem with the API itself. It's a problem the management on top of it.
Yeah, I'm not trying to point fingers, but it's a problem, right?
Yeah, the solution to that problem is whoever does the cloning of the objects needs to change the deletion policy at that time, right? That would be the only way to solve this.
Yeah.
Right. Or we had
Doesn't seem like a big
reference
deal.
counting in the back end.
That's never going to work, but we've tried it. Good luck
Or
with
we have
that.
lots about which cluster is allowed to delete things. I mean, it's pretty easy to cut your fingers off here.
Yes. So that's the problem that I was trying to surface. The proposal was like, if we decouple the lifecycle management of the volume snapshot and the storage provider with that of the Kubernetes objects, you can have policies saying, hey, if there's a volume snapshot that is not referenced or not being used anywhere, keep it around for like, say 10 days, pulling a number out of a hat. Keep it around for 10 days and delete it afterwards or something like that, instead of immediately deleting it.
Yeah, but how do you know if there's a reference to it? Like, that sort of inverts the model, right? Because in the current model, Kubernetes is on top, the CSI drivers in the middle, and the storage is down the bottom. Now you're saying
I'm just trying to surface the problem so that we can come up with a solution.
No, I get
spend
that.
More time than this 1 hour or less than 1 hour to come up with this solution.
But like, so if I had that problem, my recommendation would be like just always use the retain deletion policy on all of my Kubernetes clusters and like make deletion somebody else's problem, right? That way you'd never have an issue where Kubernetes is going to delete a snapshot and something else will have to be responsible for monitoring all the snapshots, figuring out who has references to them, and then actually deleting them at the appropriate times.
So what we need to do is we need to have these recommendations for people so they don't cut their fingers off.
That actually raises another good question, which is when you restore a snapshot, does that overwrite the existing image of that snapshot, or does it create a new one?
When you restore, you get a PVC.
Right.
You create a new volume, basically.
Yeah.
It's not going to override the existing, because we do not support revert.
Exactly.
Yeah, the restore will not mutate the volume snapshot that was taken. It is just going to provision new volumes.
So if I read that correctly, the risk of actual data loss through a restore is minimal.
It depends what you're restoring. If you're restoring like a backup of your Kubernetes cluster, then you'll get copies of the Kubernetes objects with deletion policies of delete, and then in the new Kubernetes cluster, you'll have 2 references to the same snapshot. That's the risk he's describing. And
yeah, 2 conflicting policies for the same volume snapshot.
But I mean, it's pretty easy to say, like, just don't do that. And if your workflow requires you to do that, maybe always use a retain deletion policy and figure out another way to handle actual deletions. But I mean, I don't see how a change to the to the Kubernetes API could make this any less bad. This is just a problem someone needs to solve.
That's the point of bringing it up.
Yeah, I fully agree with what Ben was saying, right? This is not an API level solution, right? There's not easy API level solution. Even if it's one of the proposal where he is introducing TTL into the CSI driver, it's not gonna solve the fundamental problem of multi-referencing, right? The same thing still stands. Because
yeah, in the TTL, that's going to create more orphans because the TTL is dependent on the CSI driver continuing to run. So if you want to take a cluster down and get rid of all of its stuff, you delete everything, you delete all the snapshots, then you take the cluster down, and the CSI driver now no longer actually does the TTL work, right?
I doubt the TTL will sit only in the CSI driver layer. You'll eventually get pushed down into the storage layer. Is that right?
Yes.
Or you need some sort of other controller that sits outside the Kubernetes cluster that's managing your snapshots for all of the clusters.
It's like a policy, some policy engine, right? You have some scheduling and retention policy type of thing.
Yeah,
exactly. If you're talking about multiple clusters, then upper level control plane is needed for sure. Because otherwise, it's really hard to solve this multi-referencing problem within one cluster. Because it just simply don't know the information from others. Is it?
So it sounds to me like there's a need for good documentation to cover this, rather than having to do that through a CSI API.
Yeah, but it would be good to document the limits and the known gotchas of the current implementation to reduce surprise.
Jim, do we have this thing document somewhere? I think so.
We have,
right?
yeah,
The
we do
behavior
have
of this
retain.
type.
Yeah, we do have a document talking about retain policy and retain and deletion. We do talk about that. That's in the Kubernetes main document. If we need to add more to clarify, then we can definitely do that.
I think we should definitely add what Ashish was saying and Ben was saying, right? That
Okay.
if you are working in a multi-cluster, a multi-reference into the same volume snapshot ID model, it is critical to understand that deletion of the snapshot can cause dangling in the other objects.
Yeah, we can add an action item, maybe add this language into that official document.
And the other thing that we kind of previously spoke about was in which case, if the recommendation is to use retain as your deletion policy, how do you actually then really delete the volume snapshot that you've taken before?
Yeah, so that you have to go delete it physically from your storage system, right? Because you delete, I don't know if you have tried this. So after you delete volume snapshot, the volume snapshot content and the physical resource still exist. And then you go ahead and just say delete the content. That will only delete the content object and the physical snapshot still exists. So for that, you'll have to go to the storage system to clean that up. Yeah.
Yeah. So I tried this with the host path plugin. What happened was, it looked like the finalizer was not being removed at all. Because of which
that's a bug. Yeah, I think that's fixed recently. We are actually now adding some E2E test to try this one. Yeah.
Okay.
Yeah. So if you try it with the latest version, then yeah.
Okay, I will try that.
Actually, I want to clarify one thing, because that bug only applies to pre-provisioned, statically bounded snapshot and volume snapshot contents. Were you creating dynamic ones? If you're creating dynamic ones, it shouldn't be that case.
He's part testing the static ones, right? Pre-provision?
I'm trying to, I have tried deleting both, and both kind of sit there because the finalizer
Okay, can you test with the latest, the 2.1 release?
Okay.
If it's still a problem, then we need to fix. But I believe those are fixed. Yeah.
I will try that.
Okay.
I'm not sure I caught the difference between the
there may
static
be,
and the
there
dynamic.
may be still one problem. If the storage class is removed, I think, and there is one problem that is just came out. There is a PR in progress for that. It's already, we're already at top of hour. I actually have one more item to give an update on. Thank you, Ashish. There's one more item to give a quick update on the execution hook design. So we basically talked to Tim about this, got some feedback from him. So he was suggesting that we should let Kubelet handle the execution of the hook. I think that's actually in sync with what we have here in the main new proposal. And then he was suggesting to have a inline pod definition for the hook, but then have another hook action API object. So have that separate. I think in our main proposal, I think everything's together. So, and then the external controller will be triggering by modifying the hook action to tell the kubelet when to run that command inside the container. And then also he wants this one to be used for not just for quiet and unquiet, but also for some other use cases when you need to send a signal to the pod to do something, to run some command. So we need to come up with an updated proposal. We need to talk to SIG-Node and SIG-Auth to get their feedback on this, because this means then we're going to make a lot of changes in kubelet. So yeah, that's the status. We don't really have a updated design doc. It's just we got some feedback from Tim. So that's it. So if we get more information, more update, we will bring it to this group to review. That's it. Anything else? Thanks, everyone. Bye.
Thank you.